What is the law of conservation of mass? What is being conserved? Well, the word conserved means to save. So in the law of conservation of mass, mass is being conserved or saved. So in a chemical reaction, mass is neither created nor destroyed, but it just changes form or just grouped differently. Therefore, mass stays constant. The law of conservation of matter states, in a chemical reaction, matter is neither created nor destroyed. And we know that matter consists of mass. So if mass stays constant, so does matter. So therefore, when we take a look at chemical reactions, we have to account for this statement, whereby we need to account all atoms. Therefore, a balanced equation is necessary to keep the same number of each kind of atoms on the reactant and product side of the equation. A balanced equation has the same number of atoms of each element on both sides of the equation. Please note that subscripts and formulas must not be changed. Taking a look here, here's a balanced equation. Here's an example of an equation that is not balanced. Notice the number of hydrogens on this side does not equal the number of hydrogens on this side. And the number of oxygens on this side does not equate to the numbers of oxygens on this side. Therefore, the equation is not balanced. Now, if we add what we call coefficients, then we can make the equation balanced. So taking a look here, we have 4 oxygens here. We have 4 oxygens there. We have 4 hydrogens. We have 4 hydrogens. And we have 1 carbon. Therefore, the number and type of atoms must be the same in order for the equation to be balanced. So what are coefficients? Coefficients are the numbers before the formula of a substance in an equation. When we did balanced ion pairs, we used coefficients. They are going to be used again in balancing equations. For example, if we take this reaction, which we have done in class, the 2 is a coefficient for magnesium and magnesium oxide. Another example, this 4 and this 2 are also examples of coefficients. And they mean that there's 4 atoms of copper and 2 molecules of copper 1 oxide. So we use coefficients in order to balance the numbers of atoms. And when we figure out if they're balanced or not, we use the distributive property in math to figure out how many atoms there are for each element in a compound. For example, if we take a look at this equation right here, where we have 2 molecules of hydrogen gas, 1 molecule of oxygen gas, produces 2 molecules of water. Well, how do we figure out that we have equal numbers of elements on each side? So what we do is we set up something called atom inventory, where we break up the reactants and the products, and then the numbers of each atom on each side. So the numbers of hydrogens, we have 4. And how did I get 4? I simply multiplied 2 times 2. And again, on this side, I multiplied 2 times 2 to get 4. The oxygens, we know, since there's a little 2 there, that there's going to be 2. And again, we use the distributive property since there's a subscript of 1. 2 times 1 equals 2 on that side. Notice how the numbers of each element are the same. That equates to a balanced equation.